Hey there, deep divers. Ready to explore some code with me today?
Always up for a deep dive.
Awesome. So today, we're looking into how Java handles those tricky what if the data is missing situations.
Ah, yes, those pesky null values that can trip up even the most experienced programmers.
Exactly. We're gonna dive into how Java Optional teams up with the Stream API to make our code cleaner, safer, and more efficient.
Sounds like a recipe for better code all around.
For sure. Our source material today is an article by Danuka Kasun-Medis, published on Medium just last month. It's called Exploring Java Optional with the Stream API.
I read that one. A really good breakdown of a powerful technique.
Yeah, I thought so too. Even for folks who aren't programmers, I think this is a fascinating peek into how we build reliable technology, like how do we make sure software doesn't just crash when it encounters a bit of missing information?
Right, because in the real world, things aren't always perfect. Data can be missing, incomplete, or just plain wrong. So how do we build systems that can handle that gracefully?
Exactly. And that's where optional comes in. So could you give us a quick rundown of what optional is in Java?
Sure. So optional is basically a container. It can either hold a value or it can be empty. Think of it like receiving a package. It might have a gift inside or it might be empty.
I like that analogy. So optional is like a way of representing that uncertainty in code.
Exactly. It's like saying, hey, this variable might have something in it or it might not. Let's handle both possibilities safely.
So it's kind of like a built-in safety net to prevent those dreaded null pointer exceptions, right? The ones that can crash a program faster than you can say debugging nightmare.
Exactly. The article even shows some basic usage like optional.ofJohn to create an optional with a value.
Right. And then there's optional.empty for those times when you need to represent, well, nothing.
And of course, you need a way to check if a value is actually present, and that's where name.isPresent comes in.
So instead of the program just crashing, if it encounters a missing piece of data, it can gracefully say, okay, I've got a plan B for this.
Right. And it's not just about preventing crashes. Using optional makes your code more readable and easier to understand. It clearly signals to other developers that this variable might not have a value, so be careful how you use it.
Okay, so we're talking about preventing crashes, making code more readable, and even making things run more efficiently. For those of you who work with Java, this is definitely a deep dive you won't want to miss. So how do we actually create these optionals? I mean, the article mentions a few different ways.
Yeah, so the way you create an optional depends on, well, how much you trust the data you're working with. If you know for sure a value exists, you can use optional.above a value.
Makes sense. But what if you're not so sure? What if there's a chance the value might be missing?
That's when you'd use optional.ofNullable value. It's the safer option when you're dealing with data that might be a bit, shall we say, unreliable.
So it's like choosing the right tool for the job, making sure your code is prepared for whatever data throws its way.
Precisely. And then there's optional.empty, which is pretty self-explanatory. You use it when you need to explicitly represent the absence of a value.
Okay, so we've got the basics of creating optionals down. But the real power, I think, comes from what you can actually do with them. What are some of the key methods that make optional so useful?
The article goes into quite a few, but let's start with some of the most common ones. And
Yeah.
a good place to start might be or else.
Or else. Okay, tell me more.
Well, with or else, you basically provide a fallback value. Like if the optional is empty, here's the default value you should use instead.
Oh, so it's like having a backup plan already in place.
Exactly. The article uses the example of fetching a user's preferred language.
Hmm.
You might use something like or else English to make sure there's always a language to work with, defaulting to English if their preference isn't set.
That's clever. But what about or else get? Isn't that kind of similar?
It is, but it's a little more, how should I say, lazy.
Lazy. I like the sound of that. Tell me more about this lazy approach.
Well, instead of calculating the default value right away, or else get, only does so if the optional is actually empty. It only kicks in if it absolutely has to.
So it's all about conserving energy and only doing the work if it's absolutely necessary, efficient and relatable. But what if you're in a situation where you absolutely positively need a value to be present? No ifs, ands, or buts.
In that case, you'd want to use or else throw.
Or else throw.
Yeah.
Okay, what's the deal with that one?
Well, it basically lets you throw an exception. It's like a way for your program to say, hey, something's wrong here. I can't proceed without a value.
So it's like a safety mechanism, right? It stops the whole operation if something critical is missing.
Exactly. It's a way to catch those potential errors early on before they cause bigger problems down the line.
Okay, I see. So or else throw is for those must-have situations. But the article also mentions if present. What's that one all about?
If present. It's a more subtle way of dealing with optionals. It lets you execute a block of code, but only if the optional has a value.
So it's a way of saying, if this box is empty, let's just skip this part and move on.
Exactly. No need to do extra work if there's nothing to work with.
So we've got these different tools for working with optionals, depending on the situation. We can provide defaults, throw exceptions, or conditionally execute code based on whether a value is present or not. All very handy stuff. But the article hints that things get even more interesting when you combine optional with the JavaStream API.
Ah, yes, the Stream API. Now we're talking. Streams are like a super highway for processing collections of data.
And when you combine them with optionals, you get this incredibly powerful and elegant way to handle potentially missing data within a larger data processing pipeline.
It's like having a team of expert movers carefully transporting your precious cargo, even if some boxes might be empty along the way.
So how do these two powerful concepts, optionals and streams, actually work together in practice? What kind of magic can they create?
Well, one way is by gracefully handling those times when a search for data might come up empty.
A search coming up empty. So it's like looking for a specific book in a library, but realizing it's not on the shelf.
Exactly. And in the world of coding, that empty shelf can cause a lot of problems if you're not careful.
Right. Because the program might try to access data that's not actually there, leading to those nasty null pointer exceptions we talked about earlier.
Exactly. But the Stream API, combined with optionals, offers a really elegant solution. The article highlights the find first and find any methods, which are commonly used when working with streams.
And these methods, they're all about searching, right? Like finding a specific element in a collection of data.
Right. And the thing is, these searches, they might be successful or they might not. You might find what you're looking for, or you might come up empty.
And that's where optional comes in, right? Instead of just returning null, which could cause problems down the line, these methods return an optional.
Precisely. It's a much safer and more predictable way to handle search results, especially when you're dealing with large data sets.
So it's like having a guarantee that your search will always give you something to work with. Either you'll find the treasure you were looking for, or you'll get a clear signal that it's not there. No more surprises, no more crashes.
Exactly. The article even gives a specific example, like searching for the first name in a list that starts with the letter B. That search might find a match, or it might not.
And either way, you're covered because the result is wrapped in an optional.
Right. No more nulls lurking in the shadows, ready to crash your program.
I'm starting to see how this combination of optionals and streams can really make code more robust. You're anticipating those potential problems and handling them gracefully. But the article also mentions these intriguing methods called map and flat map. They seem to add another layer of sophistication to this whole optional and stream partnership.
Ah, yes, map and flat map. They're essential tools for transforming data within optionals, and they become even more powerful when used in the context of streams.
Transforming data, so we're not just checking if a value is there anymore, we're actually manipulating it if it is.
Exactly. Think of map as a way to apply a function to the value inside an optional, but only if that value is actually present.
Okay, so it's like saying, if this box contains a tool, let's use that tool to build something. But if the box is empty, we just move on, right?
Right. No point in trying to use a tool that isn't there. The article uses the example of getting the length of a name using name.map, string.length. If the name optional actually contains a name, map calculates its length and returns a new optional containing that length.
But if the name optional is empty, nothing happens, right? We just get an empty optional back.
Precisely. No need to calculate the length of something that doesn't exist. Now, flat map is similar to map, but it's specifically designed for situations where the transformation itself might return an optional.
That sounds a bit more abstract. Can you give me a real-world example of when you'd use flat map?
Sure. Imagine you're working with user profiles and you want to get a user's address. But not all users might have provided their address information.
So you might have a method like get user address, and it would return an optional, right?
Exactly. It would either contain an address or be empty if the user hasn't filled in that information. Now, let's say you also want to extract the city from the address.
But only if an address is actually present.
Exactly. That's where flat map comes in. You see, if you just use map to extract the city, You'd end up with an optional wrapped inside another optional, which can get messy.
Optionals all the way down, so flat map helps us avoid that nesting.
It does. It flattens the results, so you always end up with a single optional. Either it contains the city or it's empty, nice and clean.
Okay, that makes sense. So flat map is like a master organizer, making sure those optionals stay nice and tidy, even when we're dealing with multiple layers of potential emptiness.
Exactly. And this kind of elegant handling of optionals becomes especially powerful when working with streams. The article even points out that you can convert an optional into a stream.
Wait, you can turn a single optional into a whole stream. Why would you want to do that?
It can be useful if you want to integrate an optional into a larger data processing workflow using streams. Like, let's say you have an optional containing a customer's name, and you want to perform several operations on it.
Like checking if it's in a database, converting it to uppercase, and then logging it.
Exactly. By converting the optional to a stream, you can use all those powerful stream operations on that single value.
Ah, so it's a way to seamlessly integrate optionals into the world of streams, leveraging all the tools and flexibility that streams provide.
Precisely. And the article highlights a key point.
Yeah.
If the optional is empty, the resulting stream is also empty. So you maintain that consistency and predictability.
So no matter what, you're always working with a stream, whether it contains data or not. And that makes the code much easier to reason about and maintain.
Exactly. Now, speaking of streams, they have their own set of tools for processing data, like the reduce function.
Reduce. Now that one sounds familiar. Doesn't it have something to do with combining elements in a stream?
You got it. Reduce is used to combine elements in a stream into a single result. Like, let's say you want to sum up all the numbers in a list. You could use reduce for that.
Okay, that makes sense. But where does optional fit into this picture?
Well, what happens if the list you're trying to sum is empty?
Ah, I see where you're going with this. Instead of returning null or throwing an error, reduce returns an optional.
Precisely. It gracefully handles a case where there might not be any data to reduce.
It's like saying, hey, I tried to add up all the numbers, but the list was empty, so here's an optional. It might have a sum or it might not.
And then, of course, you can use methods like or else to provide a default value, like 0, if the optional is empty.
So it's like optionals are always there, watching our backs, making sure our code can handle those edge cases without breaking a sweat. It's really impressive how they integrate so seamlessly with various parts of the Java language.
And the article really drives home this point. Optionals aren't just about preventing crashes. They're about writing code that's expressive, readable, and easier to maintain. It's about clearly communicating to other developers how your code handles those might be there, might not be there situations.
Yeah, it's like optional is speaking a language that's designed for both humans and computers to understand.
Exactly. And speaking of clear and easy to understand, the article wraps up with a great real-world example of how to use optionals and streams to process a list of names, where some of those names might be, you guess it, null.
Nulls, the bane of every programmer's existence. So how do optionals and streams help us deal with them in this scenario?
Let's say you have a list of customer names, but some of those entries are missing. They're just null values, and you want to print out all the valid names, ignoring the nulls. Pretty common task, right?
Yeah, definitely. So how would you approach that using optionals and streams?
The article gives a really concise snippet of code.names.stream.map, optional.nullable.forEach, op-op.ffpresent, system.out.println.
Okay, let's unpack that a bit. So we've got a list of names and we're turning it into a stream. Then we've got this map, optional.of-nullable part. What's going on there?
That's where the magic of optional really shines. That piece of code is taking each name from the list and wrapping it in an optional. If the name is valid, great, it gets placed inside an optional container. But if it's null, an empty optional is created.
So it's like we're putting each name into a special box, and that box can either contain a name or be empty.
Exactly. And then comes the power of forEach and if present. The forEach method goes through each of those name boxes, and for each one, if present system.out.println checks, is there an actual name in here? If there is, it prints the name. If not, it just moves on to the next box.
Ah, so it's like an assembly line. Each name goes through the process and the nulls just get filtered out automatically.
Exactly. It's super efficient and elegant.
Yeah.
You can clearly see how the code handles those potential null values without any messy if statements or null checks.
I love how this code is both powerful and so readable. You can really tell what it's doing just by glancing at it.
That's the beauty of combining optionals and streams. It makes your code robust and efficient, but also easy to understand and maintain.
Well, I gotta say, I'm feeling pretty inspired after this deep dive. We've covered a lot of ground, from the basic concepts of Java Optional to its powerful synergy with the Stream API. We've seen how to create optionals, how to use those handy methods like or else get, and or else throw, and how optionals become even more powerful when combined with streams for things like searching, transforming, and filtering data.
And we even saw a practical example of how optionals can help us gracefully handle those pesky null values that can trip us up in real-world scenarios.
It's like we've added a whole new set of tools to our coding toolkit, all focused on making our code cleaner, safer, and more elegant.
And those tools aren't just for Java developers either. The principles we've talked about, handling uncertainty, having backup plans, and being prepared for missing information, those are valuable in any field.
Absolutely. So, to all our listeners out there, whether you're coding wizards or just curious about the world of software, we encourage you to explore the concepts we've discussed today.
Huh.
Think about how you might apply these ideas of gracefully handling uncertainty, not just in code, but in other areas of your life as well.
Because sometimes the most elegant solutions are the ones that acknowledge that not everything is always perfect.
And on that note, I think it's time to wrap up this deep dive. Thanks for joining us on this exploration of Java Optional and the Stream API. Until next time, keep those minds curious and those codes clean.